So let's review what irrational numbers are. Irrational numbers are numbers that cannot be written as a quotient of two integers, and these are numbers that are neither terminating nor repeating. An example is the square root of 2, which if we put in the calculator is equal to 1.414, 213, 56237, and so on and so forth. And if you notice the pattern of the decimals, it does not have a repeating pattern, right? So square root of 2 is not just an irrational number, it is also a radical expression. So what is a radical expression? A radical is an expression that involves a root, usually a square root or cube root. These are the parts of a radical expression. Okay, so this tiny 3 over here is called the index. This is the radical symbol, and this is the radicand. So the index or degree, it indicates how many times a radicand is multiplied by itself. If the number is missing on the root symbol, it is assumed as 2, or it is a square root, just like in this calculator. There is no tiny number 2 over here. It's just the radical symbol and the radicand. So this means to say that it is automatically a square root, or the degree is automatically 2. So the radical symbol, it is a symbol that means root of again. This is the radical symbol. Next we have the radicand. This is the one of which you are finding the root. So for you to understand this better, let's talk about what a root is. So a root is the original number used before it was multiplied to itself. Let's see example 1. Say we have the number 9. What would be a number that was multiplied to itself once to get 9? The answer is 3. 3 times 3 is equal to 9. 9 is the square of 3, and 3 is the square root of 9. So if a number is multiplied to itself once, we call the answer the square of a number. If we are trying to find the roots of the square of a number, we are getting its square root, or it looks something like this if we express it as a radical expression. Okay, so example number 2. Say we have the number 27. What would be a number that was multiplied to itself twice to get 27? The answer is 3. 3 times 3 times 3 is equal to 27. 27 is the cube of 3. 3 is the cube root of 27. So if a number is multiplied to itself twice, we call the answer the cube of a number. And if we are trying to find the roots of the cube of a number, we are getting its cube root. If a whole number is multiplied to itself once, we call the answer a perfect square. So let's see this example. 3 times 3 is equal to 9. 9 is a perfect square. If a whole number is multiplied to itself twice, we call the answer a perfect cube. Look at this example. We have 3 times 3 times 3 is equal to 27. 27 is a perfect cube. Now let us try to solve for the first 10 perfect cubes and the first 10 perfect squares. So we can do that by getting the whole numbers 1 to 10. And all we need to do to get the perfect squares is to multiply these whole numbers by itself. So let's start with 1. So 1 times 1 is equal to 1. Yeah. Let's do the same for 2. To get the perfect square of 2, we multiply 2 by itself once, so that's 2 times 2 is equal to 4. What about 3? To get the perfect square of 3, we multiply 3 times 3. That's equal to 9. What about 4? 4 times 4 is 16. So 16 is the perfect square of 4. And let's try to do the same with numbers. The whole numbers 5 to 10. 5 times 5, 25. 6 times 6 is 36. What about 7 times 7? 49. And we have 8 times 8, which is 64. And then we have 9 times 9, which is 81. And lastly, we have 10 times 10, which is equal to 100. So these numbers over here, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, these are perfect squares that we got by multiplying these whole numbers by itself once. Now let us try to get the square root of these perfect squares. We do that by using our calculators. We use the square root of n. N in this case would be our perfect squares. So let's try the square root of 1. It's equal to 1. Let's try. What about the square root of 4? It's equal to 2. We have the square root of 9, which is equal to 3. And then we have the square root of 16. That's 4. We have the square root of 25. That's 5. And we have the square root of 36. Okay, that's 6. And then the square root of 49. That's 7. And we have the square root of 64, which is 8. The square root of 81, which is 9. And the square root of 100, which is equal to 10. So what did you notice when we got the square roots of the perfect squares? They actually just turned back into the whole numbers. Okay, the same thing will happen when we will compare perfect cubes and cube roots. So let's try to get the perfect cubes of these whole numbers. So let's try one. First we have to multiply 1 by itself twice. So that's 1 times 1 times 1. We get 1. So the perfect cube is 1. And then we do the same for 2. 2 times 2 times 2. We get 8. So the perfect cube of 2 is 8. We do the same for 3. We multiply it by itself twice. That gives us, oops, made a mistake. 3 times 3 times 3, which is 27. And what about 4? Let's try to find the perfect cube of 4. We do that by multiplying 4 by itself 2 times. We get 64. Let's try 5. That's 125. Let's get the perfect cube, or the cubed root of 6. So that's 6 times 6 times 6. We get 216. And for 7, 7 times 7 times 7, that's 343. And then we get 8 times 8 times 8, that's 512. We have 9 times 9 times 9, that's 729. 729. And lastly, we have 10 times 10 times 10, or 1000. Okay, so these are all perfect cubes that we got by multiplying their respective whole numbers to itself 2 times. Let's try to find the cube roots of these perfect cubes. So let's see, in this calculator, shift to get the cube root of 3. So if you notice, the degree is now 3. A while ago, the degree was 2 because we were getting the square root. But since we are now getting the cube roots, the degree is 3. So let's get the cube root of 1. The perfect cube 1, that will give us 1. Let's get the cube root of, oh, of 8, which is 2. Let's get the cube root of 27. That gives us 3. And then the cube root of 64, that's 4. And then the cube root of 25. Oh, sorry, it's 125. My bad. 125, which is 5. And then, okay, the cube root of 216 gave us 6. Next, we have the cube root of 343, or 7. I mean, that's equal to 7. And then we have the cube root of 512. That's 8. And then we have the cube root of 729, which is 9. And we have the cube root of 1000, or 10. So I hope you were able to see the pattern that happened here. If we want to get the perfect square of a whole number, we just multiply the whole number by itself once. And then if we want to get the whole number back, we just get the square root of the perfect square. The same thing goes for the perfect cubes. We get the perfect cubes by multiplying whole numbers to itself twice. And if we want to get the whole number back, we just get the cube root of the perfect cube. Okay, now I want you to pause the video and try to solve for the next 5 perfect squares after 100, and try to solve for the next 5 perfect squares after 1000. The answers you should get is this. This is for the perfect squares, and this is for the, oh, sorry, this is supposed to be perfect cubes. My bad. Try to solve for the next 5 perfect squares after 100, and try to solve for the next 5 perfect cubes after 1000. Okay, these are the answers. The answers are here, but I want you to figure out how we got these answers.